This is StarTalk Sports Edition, a Cosmic Queries version. We're going to talk about the Winter Olympics. Ooh, yeah. We got Gary O'Reilly.
Hey,
do they play soccer in the snow? Do they play soccer in the snow?
Yeah, we will do. It depends if it's too bad, no, because the ball doesn't roll. But yeah, we'll play frozen and in the snow.
I gotcha. And Chuck, you avoid cold weather at all cost.
Yes, it's an homage to my ancestors.
In the depths of Africa.
Yes.
There's no snow.
Yes. Yes. For all that came out of the Serengeti, I'm representing.
So this is a very broad topic because we want to talk about the Olympics in general, the Winter Olympics, the events, the fact that it's in Beijing. And, anytime we have a broad subject like this, there's only one go-to person, and that's our geek in chief, the one and only, my friend and colleague, Charles Liu. Charles, welcome back to StarTalk for the 100th time.
Thank you, Neil. It's my pleasure. Thank you. Hello, Gary.
Hey,
hello, Chuck.
Charles.
Or should I say Lord Nice?
Oh, my God.
Nice. You were on that episode. Yeah.
Does everybody know
Charles
that
Liu
it was
was-
Major General Deanna Burt that anointed Chuck Nice with this title?
With the lordship, she certainly
Yes.
did. Yeah.
And it comes in.
was a
It comes in, and I always forget, and people remind me. So Charles, you are a professor of astronomy and physics at the City University of New York at Staten Island, and
Correct.
You recently become chair of the department. Is that correct?
Yes, and it's been fun. I have some great colleagues, some wonderful students, and if anybody watches The Chair, the TV show that's become popular lately, that's like 5% of maybe my regular life, but it's a lot of fun. I have a good time with it.
Okay, so I smell a reality show in the making here, where Charles Liu really shows what this is about.
Yeah, we'll call it the lounge chair.
Good one, Chuck. Good one.
The settee.
Chuck. And Charles, hearing from the grapevine, you've got a podcast in the making. So we all look forward to seeing that post. And
Thank you.
You told me offline that it's called the Luniverse.
Yes.
I see what you
The
did there.
Luniverse, yes.
Charles Liu.
I didn't come up with it. Family members around the dining room table, they were like, why don't you call it the Luniverse? I said, really? They said, yeah, sure, why not? So
Luniverse.
it should be
Very
fun. We're really
good.
looking forward to it. It should be a lot of fun. We're talking with fun folks. We'll have a good time.
Excellent, excellent. It's a Cosmic Queries grab bag on the 2022 Olympics taking place in Beijing. So the questions are open for anybody and anything. And Gary, Chuck, who between you has the questions for us?
I think Chuck and I can share them between ourselves. Let us kick it off. Welcome to Charles, obviously. Great to have you back. Right. Michaela Nagus. These are all questions from our Patreon listeners.
I'm sorry, what you call me?
Michaela Nagus.
Oh, okay. Oh, okay.
All right.
I got nervous for a second.
All right, just working on my pronunciation here. I couldn't trip up on that one too quickly, could I? So, why does the temperature of Olympic ice need to be different for figure skating, speed skating, and hockey? Could an ingredient be added to the ice to make it more ideal for the athletes, for example, making it smoother, harder, softer, etc.?
Wow,
Yeah.
I didn't even know that. Chuck, Charles, did you know that?
Ice changes
course you
all
do.
the time.
Okay. Sorry.
Ice is being Ice for
First,
sports.
basic fact. Are all three of those ices pure water, or have they added anything to it?
Usually things have been added. They are often pure water, but if they are pure water, even then there's changes because they change the temperature. They freeze it at different temperatures, hot or cold. Just because something is freezing doesn't mean that it stays at that same sort of texture and temperature the whole time. This is actually used on purpose in a lot of different places. There's a famous example in ice hockey, in college hockey. Depending on where you go to play your hockey, the ice is either really fast or really slow.
Yeah.
Depends on their team.
Wait, is this like the deflate gate with Tom Brady, where you can change?
Well, no, that happens naturally, Neil. So, for instance, the Canadians have, Charles, back me up on this if I'm right or wrong. The Canadians have just historically hard ice, but if you go and play hockey in LA and someone's left the arena doors open for a while and that hot air comes in, it affects the quality of the ice.
It totally does. And the refrigeration underneath the ice, of course, can be strongly adjusted to any situation if you have an indoor rink, right? So what happens with indoor activities...
Wait, Charles,
for example,
I just establish here.
Yeah.
Wait, I just have to establish here because I think some people might not know this. I think you were hinting at it, but let me just drive it home. Water freezes at 0 degrees Celsius, 32 degrees Fahrenheit. And we call that ice, but you can have ice at any temperature below that. And the properties are different depending on what temperature the ice is. So ice is not ice is not ice. It depends on how cold the ice is. Okay, is that I think I got that right.
Yes.
Okay, now the handle.
That is exactly true.
And at what temperature does it get down to gangster rap, like Ice-T and Ice Cube?
Well, nice that you should mention that. On Titan, right, the moon of Saturn, the temperature of the ice is hundreds of degrees below 0 Fahrenheit. And so the water ice is as hard there as granite is here on this Earth. So they build mountains with it. You can see all kinds of geological features that's built with water ice that you could not do here because the moment you
Wait, what do you mean they built the ice? You're talking about aliens on Titan?
I was going to let that one
they
go.
Built the ice.
Oh, that's an excellent point. Who is they?
They built mountains on Titan. Yeah.
But the answer, bottom
you're not
line,
allowed
Gary,
to divulge
get back
anything
to
more
science,
than that.
That's Yes, Gary. The temperature varies, and each rink does its own thing, and each sport has its own regulations as to what you are allowed to do in terms of temperature, in terms of additives, in terms of those sorts of things.
Yeah, the hockey players don't like soft ice because the puck doesn't move.
Some hockey players love soft ice. Think of the very large, bulky folks who, like the Wayne Gretzky's of the world, would zip right by.
The slow guys. The slow guys like the softer ice.
Yeah, and there are famous or infamous examples of really good hockey teams with fast skaters going into a visiting rink where the players are slow, and suddenly it's like they're on molasses, and you see like water spraying
Tom Brady
off their
letting
ice.
the air out of the ball.
Yeah.
That's Tom
Kinda
Brady
like
letting
that.
the air out of the ball.
Very kind of like that, yeah.
So is it possible to get ice so hard that like a speed skater's blade wouldn't even allow it to turn? Like you would literally skid across the ice instead of skate across it?
On Earth's surface, probably not.
Okay.
But elsewhere in the universe, for sure and absolutely.
Ooh.
Oh, cool.
Ooh.
Okay, so it's all about what kind of speed that they want. So figure skating versus hockey versus speed skating, then it's pretty clear. You can put that on a chart.
You kind of can, yeah. And remember what the skates look like, right? A hockey skate is straight. The blade is straight. The figure skate's got a little divot-y thing right at the tip, so you can dig into the ice and jump up and do your spins and things like that. And if your ice is too hard, then
it doesn't
you can't
make a
dig
difference.
effectively, right? But if it's too soft, then you also can't dig very much because you got this sort of layer of soft stuff. So, yeah, people have to adjust very, very carefully.
So, Charles, one other thing. Why are speed skates longer in their blade than hockey skates?
I presume that has something to do with the ability for you to push off and get higher velocities going in a straight direction, right? I mean, Gary, you're probably more an expert about in terms of the relationship between how long you can push, say, off the ground or something, and thus how much stride you can get or how much speed you can pick up, the kind of acceleration or explosiveness.
Is there a relationship to the amount of time the skate stays on the ice and you're able to impart energy through that? So therefore a longer skate allows you that fraction more contact with the ice and therefore pushing energy in to get push out.
Yeah, I bet you that's true. And if you want to stop, too, a longer blade gives you more. When you're at a 45 or 90-degree angle, you're able to brake faster, right? Because you have more of a surface with which to push friction against the ice.
All right, so, okay, yeah, more
Of course,
questions.
we have a very curious audience, Neil. All right, Dylan, or DeLeon, if Chuck prefers me to pronounce it like that. Hello,
Badly.
Dr. Tyson, Dr. Liu, and our great comedic co-host. Yes, of course. I love to ski and have always wondered something. This is from Dylan, of course. Snow and ice aren't exactly the same things, and we know ice has a thin layer of water, less than the width of a bacteria, he believes, which makes ice sports possible, such as skating. Does skiing also have to do with pressure melting, or is there something else going on with snow?
Wow. The answer is both are true.
Ooh.
The snow isn't even...
First explain pressure melting. Explain
Yeah.
that.
Well, there is a relationship where if you have more pressure on water or ice, it is more likely to melt. This is untrue for most substances, but the more you push on something, more you push on ice, the more likely it is to be able to liquefy. This is a particular property of ice which is rare amongst substances here on Earth, and that allows us to be able to do these things like skate across ice with that tiny film of water, that bacteria with filled water that we talk about. But it's a very complicated system.
Wait, what is the molecular transaction that's happening where pushing pressure causes melting? Because that's how they make the big ice balls for my scotch, which I never.
That is how they do it. Right?
Yeah, I never
How you make a
questioned it.
snowball. You take the snow, you smush it. Whoa, there's your ice ball.
Right.
Yeah,
I never question it because I'm about to drink some scotch, so I don't care.
Well,
But what is the molecular transaction that the pushing makes the melting?
Well, we shouldn't get too deeply into the specific chemistry right now because it takes a long time to sort of make the descriptions. But basically, a water molecule is a V shape, right? It's got the oxygen in the middle and it's got two hydrogens off to the side, making kind of a V. It's a polar molecule like this. And when ice freezes, it has a tendency just to touch on the hydrogen bonds. It doesn't want to just squish in, but it wants to form a hydrogen bond lattice or a crystal. And as a result, it winds up with extra space between the molecules, space that would not have existed in its ordinary liquid form. Okay. And so that basically allows all kinds of strange things to happen. And so snow is ice water, right? It's solid water, but it's in small crystals as opposed to one big slab of solid material. So when you pack a whole lot of little things together and you create a surface, it's a different surface altogether from if you have a single slab of the same object, everything stuck together. The difference between, say, a sandstone walkway and a sandy beach. So snow gives you even more variation on, say, going across its surface than the sliding across a slab of ice. So the answer to the question here is indeed that snow variations, changes, temperature, pressure, weather, wind will make all the difference in the world when it comes to a snow sport.
But in fact, if you ski a lot on a fluffy snow slope, it eventually becomes sort of, you've melted many of the surface layers of crystals,
Right.
of snowflakes, and eventually it just becomes icy.
Yeah.
It's no longer fun to ski
You will
on,
start
right?
packing it down
right.
more and
Right.
more and
Start
more.
packing
Then
it
again,
down.
if you're in competition, Neil, you want to go faster. So icy, quicker, fluffy, powdery snow, slower.
Yeah, but there's a very delicate equilibrium that you have to find because if it's too icy, you can't turn. So in the giant slalom, you want a kind of nice balance between that powdery and that icy so you can grip with the edges of your ski, but yet at the same time you can achieve the turning. So you have the fast and the turning at the same time.
Chuck, you know the deal. If it's too icy, you find the nearest tree. because you just in a straight line. Right.
Wait, Chuck, we established in a previous episode that we're not taking skiing advice from
Yeah, we are. Yes, we are.
We're not.
Oh, we're taking
not
skiing advice from Chuck.
No skiing advice from the dude who's sitting by the fire in the lodge. Yeah, I'm sitting by the fire with some brandy, just like, you do realize the reason you weren't able to turn was because.
Before we take a break, I want to add something to what Charles said. So, because water expands when it freezes, it can only exist in that expanded state as ice. If you successfully squeeze it, it cannot be squozen as ice. The only way you can squeeze it is for it to change state and then become smaller in its volume.
Wow.
And so that's why. So you're skating on the ice, the pressure forces it to turn back into water even at the lower temperature.
Wow.
That is exactly right. And then if you're going down a ski slope or a toboggan slope, or, like a bobsled or something, remember, a lot of that stuff is outdoors. So what if it starts to snow? Then you have even more stuff on there. It gets even more complicated. Mm-hmm. The weather makes all the difference in the world. I remember 1984, I think it was, Sarajevo Winter Olympics. Billy Johnson, the American, was the first person down the mountain. And then the weather got worse and worse and worse, and all the rest of the competitors could not keep up with that first time, because that first time was the ideal condition, regardless of what anything else happened with the surface, because the atmospheric conditions had changed.
Cool.
Dude. All right, we're going to take a quick break. When we come back, more Cosmic Queries grab bag on the Winter Olympics with our geek in chief, Charles Liu. We're back. StarTalk, Sports Edition. Cosmic Queries grab bag got Charles Liu, who's our go-to person anytime we're all just confused about everything.
It's always a pleasure to be here, Neil. Always fun to chat with everybody.
So we're just pulling questions out of this grab bag, and Chuck or Gary, who's got the next one?
Okay, I'll jump in. Right, Eric Varga says, "Hello, Dr. Tyson, Dr. Liu, but he's downgraded you, Chuck. You're now Sir Chuck. You've lost your lordship, apparently."
How dare you.
He doesn't know. He doesn't know that Sir is less than Lord. He doesn't
Oh, God,
know
yes.
that.
Yeah, he does now.
Or
Okay,
maybe he's very well aware.
all right. Can you explain how Newton's 3 laws apply to the sport of curling? Are there any other laws of physics involved that play a vital role? In advance, he says, thanks.
Wait. Did the word sport and the word curling show up in the
Absolutely. Absolutely.
Don't be such a snob. Curling is a distinguished sport.
I'm mortified.
Go. Neil,
It's
curling,
mortified.
curling is one of the oldest team sports in existence. Look, this show's going to come with a history lesson whether you like it or not, right?
Okay.
So, first invented in Scotland, and the first documented match was between a monk and an abbot in Paisley Abbey in Scotland in 1541. So the moral of this history is, when you lock people up in a monastery for a long time during winter, they come up with curling. Just saying.
Curling, the sport of sexual frustration everywhere.
So, about Newton's 3 laws of physics and anything else you can throw at curling.
Yes. Well, Newton's 3 laws, as most of us know, is that first law, right? An object in motion tends to stay in motion in a straight line unless acted upon by an outside force. So the guy pushing the stone forward, it's just going to keep going and going and going, and that's why you notice that it keeps going and going and going unless acted upon by an outside force. Okay? Now, the second law of motion, force is mass
Wait, just to
times
be clear,
acceleration.
it keeps going because the friction is very low. Otherwise, the friction would stop it, right?
Well,
so
you are front-running me on that point, Neil. You're absolutely
sorry.
right. No, it's good. It's good.
Okay, go ahead.
See, because you're doing exactly what scientists should be doing, right? Which is jumping in and saying, but, right? And the but is Newton's second law, which, as you know, is force is mass times acceleration.
It's also Sir Mix-a-Lot's first law.
I like big... Okay, never mind.
All right, go ahead.
What is creating the mass times acceleration, right? That's the second thing. That's what Neil is bringing up. And friction, as it turns out, will cause mass times acceleration to be exerted on the stone that's moving forward. And so the second law requires that you wind up making sure that the friction is just right. So the amount of force and acceleration that you get, the change in direction and then the change in speed, is what you want. So those guys in the broom up front, they are quickly changing the coefficient of friction of the ice on the whole time. The brushing, I've never known if exactly before every run, the curling people put like a whole bunch of snow or shaved ice on the track.
No, Charles, back in the 16th century when curling was invented, it was taken place on frozen locks and frozen ponds. So what you have now with indoor curling ice is pebbly. It's not a smooth silk finish, it's pebbly. So what the guys with the brooms are doing, they are taking away those pebbles as much as they can in a certain way. And the big clue about what this sport's all about is in the title, curling. Because a stone will curl maybe 3 times on its way to the target, or it might curl 10. But the deviation is there.
And therein lies the third law, Newton's third law of motion. When it reaches its destination in the curled direction it wants, it hits other stones. And for every action, there is an equal and opposite reaction. Mm-hmm. That's Newton's third law. So the stone hits the other stones that are in the scoring area, either knocks them out or pushes them a little bit. So Newton's laws of motion are involved in all stages of this exciting, thrilling, super fast, high energy sport called curling.
Yeah, man. Let me just say this. As a former janitor, curling is the best sport ever.
Wait, so Charles, something I never thought about.
Yeah.
So as they're brooming material into the path of the I keep thinking curling stone. They can slow it down, but they can't speed it up because it only has the speed it has at that moment. But they can also change its direction.
Yeah, absolutely.
By putting more friction on one side of it than the other.
Right.
Man.
Right. So the physics of the brooming people is extremely significant. The push, once the pusher pushes the stone off, his work is done. And all the rest of the team has to figure out where to push it forward based on the pebbliness or the shaviness of the ice.
So here's something to add to this conversation. As I think you'll understand, I don't get a chance to do this very often, but the curling stone is not flat on the base. It's actually concave, so it has a rim around it. So when it's traveling forward, the likelihood, and please disprove me, is that there's a little tilt on the front edge, which causes a little bit more friction, and then you've got an added rotation to the stone. So is that making sense to you, Charles, as I explained it?
It does in an important generalized way. We talk very glibly about ice melting and pushing and things like that, but actually the surface physics, the connections between surfaces of ice and curling or skis or anything like that is still rather poorly understood. A lot of it is still under experimentation today at the highest levels. What happens when one surface touches another? And that physics right at the edge there remains mysterious in a lot of different ways. So many hypotheses have to be put forward, and then they're either confirmed or debunked depending on the circumstances of the time. But it's a very complex question. So what you bring up is definitely an area for future study and research.
I would add that if you've ever gotten your brakes changed on your car, generally the front brakes wear out sooner than the rear brakes, because when you stop the car, the momentum of the car is carried more in the front wheels than in the back wheels. So Gary, that's my conduit to what you said, where if it's going forward and there's any friction slowing it down at all, that front edge is going to respond to it more significantly than the rear edge.
Then again, you'll have to go from front-engined vehicles to mid-engine vehicles where there's weight distribution. But that's another conversation for another time. But I think, Charles, you've given us an
Charles,
idea.
What do you know about that? In a rear-wheel car, isn't it still the front brakes that get most of the...
It varies a lot.
Wear?
Again, if you're driving
it might change if you just move the engine to the back.
Right. Well, it depends on if you're moving on a flat surface or whether you're climbing hills. Are you stopping a lot while you're going upward or downward? You are pushing more of your mass and force forward to the front, because a car, even though it feels like a rigid body, actually has a great deal of give to it, right? A lot of springs, a lot of flexible parts to it. So it's not a dead set thing. With our typical driving in suburbia, for example, I think, Neil, you're right on. But the complexity of driving gives us all plenty of fodder or area to be right or wrong on these.
What about the Flintstone cars?
Well, you should check out Fred's heels.
Yeah.
Now, those brake pads are some serious calluses.
All right, let's jump to another question. On all these questions from our Patreon listeners, so we're grateful for that. Artist formerly known as James Smith, hello, doctors and lords. Chuck, congrats on your land in Scotland. So there you go. Quick question. Bobsledding is an awesome sport to watch. How many Gs are the bobsledders experiencing at top speed? And also, are there Zambonis for their eyes like in skating?
Oh, that's cool.
Good question.
Cool.
Yes. The answer, let's see. The Zamboni question first. There actually is a lot of grooming of bobsled runs.
Ooh.
I do not know exactly whether they drive a vehicle down.
Can you imagine?
Like a little crawler. I do not know if that's the answer. But they pour water down them. They sculpt them. There are things that are made and changed. The channels are changed. The temperature is controlled. So there is a lot going on that's Zamboni-like on a bobsled run. That's 100% true.
And during the competition, there are like track grooves that are created by the former runs.
Right.
Yeah.
And you have to actually compensate for the track grooves that are already there. The person who is actually pulling the two cords
driver
to
of the
steer
sled.
the
Levers,
driver. Yeah. So
Yeah,
it's
you're
pretty cool.
absolutely right,
Chuck
Chuck.
at the fireplace sipping scotch.
Once again, I'm down to the lodge. I'm just like, you do realize that you didn't account for the track grooves. This is your problem, sir.
Also, I want to add one thing before we take a quick break. The G forces you feel have nothing to do with how fast you're moving.
Ooh.
They have to do with how fast your velocity is changing. So their biggest G forces, Charles, are going to be like when they bank the turn, right?
A G, A G is the acceleration rate of 9.8 meters per second squared. The amount of acceleration you feel when you're in free fall near the surface of the Earth. I did a quick calculation just now in the past 30 seconds in my head. So I'm not sure if it's exactly right. You can't quote me on this. But based on what I think, how fast they're going down the hill, the angles of the turns and the velocities and the banks and so forth, you're probably hitting at least 3 and sometimes 4 times of gravity. So 30 to 40 meters per second squared of acceleration. So 3 or 4 Gs is my top of the head answer. I'd have to go back and do more calculation to make sure that that's off my head.
All right, let's take a quick break. When we come back, more with Charles Liu, our geek in chief, who's breaking down the physics of the Winter Olympics when StarTalk returns. We're back. StarTalk Cosmic Queries, Sports Edition, the Winter Olympics, all kinds of questions. We're good here. So, who's got the latest one?
All right, here we go. Next up, Kevin the Sommelier. Hello, Chuck, Cubed, and Gary. You're going to love the ending on this one, Neil. This is not so much a science question, but a Seinfeldian observation. Does the luge and the skeleton... Well, we'll see. Does the luge and the skeleton events just seem like a drunk friends dare keep drinking up? There, yeah, I told you'd like that. Kevin the Sommelier.
Yes,
Nice one.
I am certain the luge is for crazy people.
Yeah. Oh, you can imagine someone up the top of a mountain, sat next to Chuck with an empty bottle of scotch, says that tray over there, I could beat you to the bottom of the mountain.
On the tray.
How many of... Wait.
Wait a minute. Which one is head first?
Skeleton
is head first.
That's the skeleton, okay.
Luge is feet first.
Mm-hmm.
Okay.
Yeah. I feel like luge is like safer, right? But how many of you have you all gone down a hill in a sledding? How many of you have you? 3 of you gone sledding before?
I mean, we have all been children, Charles. Yes.
Yeah. But we've not done it on an ice track.
Right. On an ice track as an adult.
No.
You know?
Oh, no.
Or
No
the
chance.
closest I came to that once, I was on an icy hill. or it was maybe 40 feet tall.
Wait, Charles, I
It
gotta
was
interrupt.
fantastic.
Wait, Charles, I gotta
Do you know
interrupt.
how awesome it feels to go
Charles,
down
I
at zillion
learned
miles an
from
hour
Chuck.
on the ice?
I learned from
What?
Chuck yesterday. There's common sense and there's black people
Black sense.
Okay.
That's right. There's common sense and there's black sense.
Black sense. And so, as an adult, if you're going to say, sit on this tray and go down this icy tube at 199 miles an hour, we're going to just say no. Okay?
Yeah, my answer is, if you tell me to go down a tube head first at 100 plus miles an hour, my answer is, why don't you just shoot me? I'm here. Why am I going to do the work for you? Why am I doing the work for you? You want to kill me? Go ahead and kill me. I'm right. Go ahead, do it. Do it. I'm right here. I'm right here. Go ahead and do
One
it.
good arm. I don't have the sense, I'm sorry, but I'm really glad in that instance I didn't, because going down that hill, basically ice, on basically a sheet of plastic, at a gazillion miles an hour was one of the most fun and exhilarating and awesome things going on. And there are other people, many of them kids, but also some adults going by me, some of them faster, some of them slower. Some of them piled up at the end of the hill. It was so much fun.
Charles, you know who gets to say that? The people who didn't die.
Yeah.
There is a survivor bias, I admit.
Okay, Charles, just to tap the brakes, pun intended on this, for Luge and the skeleton, they don't have any.
Yeah.
There's no brakes on the luge or the skeleton, so there's the chance of an impact, which is not my best thought.
Well, you know, we shouldn't understate the danger. Every year, professional lugers are killed. Professional skeletoners and bobsledders are, they die from.
And
not
you know
making me
what's
do
funny?
this.
Wait, I'm so glad you said that, Charles, because it's the only sport where they don't show you when it goes wrong. NASCAR, Formula One. Things go wrong, you see the car disintegrate, break apart, and then you see the guy crawl out of the cage. Even for years, ABC Wide World of Sports had a guy coming off a ski jump, and they called him the agony of defeat. Yeah. You will never see anybody promote what happens when the luge goes wrong.
Yep.
Yeah, because it would be ugly.
Yeah, because the guy shoots out of the tube.
Very, very ugly.
Yeah.
No.
They don't even They don't even follow it with the camera. The guy shoots out of the tube, and then the cameraman goes,
There are some things.
Yeah.
There are some things. All right, let's move on. And it
Another
wouldn't be
orbital
the same.
satellite launched. Okay.
Yeah. Okay. This wouldn't be the same with a Sports Edition grab bag if we didn't have Violetta and Mum Izzy asking a question.
Violetta!
Hey, okay.
Great to see you.
She has now dubbed herself as Astrophysikid.
Oh, that's
Excellent.
kid. Wow,
Nice.
that's
Good
nice.
choice.
Yeah.
Good
Okay.
choice.
Is she like 18 by now? Hasn't she been asking questions for like 20 years?
13 and 1/2, Neil.
Okay.
13 and a half. Okay, fine.
Yeah.
All right, the question
I
is
hope
this.
we're not being catfished, and one day we find out that Violetta is like a 43-year-old dude. Hello, Neil. Hello, Charles, Gary.
Yes.
My name is
right.
Violetta, and I have a question.
All right.
What
do
are
you got?
some of the craziest sports, past or present, ever to be included in the Winter Olympics? I can't imagine there was throwing the axe while skating on ice, but that sounds like it should have been back in the day. I will enter one sport in here, the 90-meter ski jump. I am going up a really, really high tower. I am icing down a ski slope and jumping and trying to fly. Now, if that isn't crazy, then I don't know what is.
No, isn't she talking about events that are no longer there? Or just, are we picking crazy events that they've
Past
got now?
or present? Past or present, Neil? Was
Right.
the,
So, Charles, are there defunct sports in the Winter Olympics as there are in the Summer Olympics? They don't have the
must
tug of
say yes.
war anymore, or the
Right.
or the rope climb.
After, we did this kind of question for the Summer Olympics in a previous episode. After that, I went and took a look at the previous sports because I just found it so fascinating. And here is the one that I found for Winter Olympics, which I think is the wildest and most interesting one.
Ooh.
It's called Mountain Military Patrol.
Really?
In the 1924
All right.
Winter Olympic Games, there was a sport called Military Patrol, where 4 military officers, 1 officer, 1 non-commissioned, and 2 privates, carrying backpacks totaling at least 50 pounds, and carrying rifles except for the officer who carried a
course.
pistol. The officer carries a pistol.
And no backpack.
They had
No
to.
backpack.
Yeah, right.
And he's got a snowmobile. But other than that,
The four of them together had to climb at least 3,000 feet in elevation on cross-country skis going at least 15 miles. And then once they got there, shoot. Then do target practice.
Okay, that sounds to me just like a way that America found to invade another country.
But this is French. And this is Swiss.
Oh, these are the
This
Swiss.
This is European.
Oh, so
Yeah,
this would have
Winter
involved.
Olympics.
So this would have involved the officers sitting at a table while the privates practiced their shooting, and he drank cognac and while eating brie.
I couldn't tell you, but apparently this was a sport.
was
And
that,
these
a one,
teams-
was that a one-time appearance, or did they?
It showed up again as a demonstration sport several times later, but it has been discontinued since about 48 was the last time it was a demonstration. But imagine that, a sport where you have a team of military officers skiing and then climbing and then shooting at various times, while all carrying heavy backpacks. That is a sport.
So that became the cross-country pentathlon, I guess. What's
Yeah.
the one where they
That's
cross-country?
Biathlon today,
biathlon.
right?
Oh,
the
And that's
biathlon.
evolved to a biathlon where you ski, shoot, ski, shoot, ski, shoot. But nowadays, those rifles are very light caliber. They're heavy, yes, but much less heavy than a true machine gun or a weapon that actually a military person used to use. And now that it's really a streamlined sport that combines the skill of shooting, target shooting, not actually military shooting.
Charles, you sound
with
like
the swimming.
the grandpa on the
through
porch.
the water.
Back in my day, the rifles were heavier, and we had to climb uphill both ways and then shoot. Now,
Yeah, maybe.
And we shot at each other.
I
You should see how many bullet holes I have right now from the Olympics.
have been very fortunate in my life, never have to fire any kind of weapon in anger, and so I cannot speak for what is easier or more difficult.
All right,
But
what
I
a
can give you the
qualifier,
numbers.
Charles. What a qualifier.
I know, right,
In
right.
anger. I shot the guy after I calmed down.
Don't dredge up that
was
memory.
I don't even want to probe that qualifier. Chuck. let that one go.
All right, do we have time for another one? Hopefully.
Yeah, Stuart. Yeah,
Charles
make another
Macco.
one.
Hello's Dr. Tyson and Liu. What impact, Chuck and I, we're not here. What impacts will climate change have on Winter Olympics throughout the rest of the century? Of course, some sports are already played indoors like skating and curling, but might we see an end to sports that require outdoor cold temperatures?
You'll see an end to them in different parts of the world where they traditionally existed. Remember, with global warming, like 100 million atomic bombs worth of extra energy floating around in the atmosphere at any given time, right, for every degree change in Celsius. There's going to be a lot of motion. So some parts that were traditionally cold will get warm, and some parts that are traditionally warm will get colder, right? So in Switzerland, for example, or in parts of France, the famous ski areas, Chamonix, places like that, they're already having real trouble getting enough snow to have a decent recreational ski season. So their sports seasons have been severely curtailed already, and that's true. Other places where currently nobody goes to, though, maybe certain areas of mountaintops, certain places where polar vortices coming out from different parts of the Arctic will create new flows of cold. Those areas might get much more snow and much more ice than they do today.
Yeah, but
And then
no one has
those
put a
areas-
ski slope there yet, so that this
Right.
would
So
change
it
the
will
business
change-
landscape.
The entire landscape will change. You're going to have a world where the sports will still continue, but they'll be in completely different places. Places where there are no ski slopes or winter resorts today, they will be there. And in other places where there were for decades, maybe even centuries, those places will struggle. That's what's gonna
Welcome to
happen.
the 2050 Olympics of Winter here in Fiji. So,
It's going to be weird. It's going to be strange. We all have to adapt.
I mean, by
Gary, give me another one.
by this time the show goes out, we'll have done our ice and snow show, and we have a great guest, Dr. Peter Veals, who makes artificial snow. So maybe he is the vanguard of a boom industry
Yes.
making powder snow.
There it
We
is.
shall see. Right, one more question.
Slip in one more, Gary. See if we can get it.
All right, Anna C. Hickman. Hello, all. I have a question about Paralympic athletes and a future time somewhere when I am probably already dead. As a wheelchair user, I am an avid follower and participant in adaptive sports, and I know sometimes there is chatter about how an adaptive athlete has some advantage because they use specialized equipment when compared to regular athletes. If we as a human race got to the point where we had outposts in space and there was interplanetary Olympics, would an athlete who already knows how to navigate in a compromised body when compared to able-bodied athletes have an advantage in competition? Would the roles potentially be reversed and the para athlete be the one with the perceived advantage?
I would totally see that as a real possibility.
Yeah, I mean,
Without
as would I.
question.
Yeah,
Without question.
I think what we declare to be an advantage or not, it's according to some norm that someone establishes. But you can imagine constructing sports where whoever was previously advantaged now becomes disadvantaged. I mean, you can come up. I mean, look at how random sports are anyway. Take this ball and put it in a hole or in a hoop or jump or crawl or
Curling.
Curling. So I welcome your follow up on this, Charles. But it seems to me that we've created a world where para athletes are trying to do what non-para athletes, what has been invented and styled for para athletes. Imagine a whole set of competitions designed specifically for para athletes, and then they have the advantage, right? So a new world, like you say, if you go into space, you go into zero G or low G, all the dynamics changes about who's good and who's not good at some sport. So that's a fascinating new world. I think it's underexplored in people's creative ways.
Yeah. I have very little to add to that, Neil. I think you're 100% right. And just our understanding of what is able-bodied and what is a compromised body varies with every environment that we go into. New sports are invented all the time. A lot of times we forget. Right, we were just talking about military patrol, which is no longer being done anymore. But that was a real sport in the 1920s, right?
Or an advertisement for officers' training school.
You don't have to carry the rifle, right? We should always be adapting to new places and always looking at human beings as whole individuals. And when we see what an environment provides for sport and recreation, we should leap on it and find it and use it and make it our own, regardless of who's out there, and turn it into fun. That's what the Olympics should be in the end, right? Fun.
And the only difference is, going back to what Neil said about the fact that para athletes have to do what able-bodied athletes do. If it were the other way around, take the able-bodied athlete and make them compete in the same Paralympics, they lose every event. Like the gentleman that we had on that shoots, who is
Archery.
the archer,
The archer.
who does it with his feet. Let any archer try to do that, and they lose.
Right. Yeah, Matt Stutzman was the guy. Right.
That's
right.
it, Matt.
Well
Stutzman.
remembered, Neil. Yes.
One of my favorite episodes. All right, Charles Liu, fellow astrophysicist, geek in chief, and wherever I am on the geek spectrum, he is beyond that.
You are too kind, sir.
All right.
Only on this show is that a compliment.
There you go.
All right, Chuck. All right, Gary.
All right, thank you.
This has
a
been
pleasure.
StarTalk Sports Edition, Cosmic Queries Grab Bag, all about winter sports. Neil deGrasse Tyson here. Keep looking up.